Okay, there we go. So we're recording now. So all of these recordings, any of the ones that I missed, I think I missed two that I didn't upload to YouTube. So those will be posted tonight. Any questions on anything that was just discussed, any of the boilerplate stuff before we actually get to the, the math element of the math class? Okay, so no hands raised, no questions. I guess we're good to go. So let's go ahead and get into the homework, or again, the midterm review. Either way, whatever you guys have questions on, I'm for it. Also, going into Wednesday, remember, I'm not gonna have anything prepared at all for Wednesday. So it's whatever questions you guys have. I expect you guys from today into Wednesday to prepare, questions over the course of whatever material that you struggled with or have questions on. Bring that to our meeting Wednesday. If we don't have any questions on Wednesday, then class is going to be real short. Okay, Keji, 72 on the homework. Sure, let's take a look at 72. Okay, so for 72, let's take a look here. It's asking us to determine whether the lines are parallel, perpendicular, or neither. Okay, so parallel, perpendicular, or neither. So let's look at our lines. So I'll call this one line one. Again, you generally, when you're talking about lines and you're trying to distinguish them, you generally call them, with a cursive L. So maybe that did not look like a cursive L. We'll try that again. There we go. That's a little better. So line one. Line one is y is equal to 3x plus 1. Okay. And then over here, line two, we have 6y plus 2x is equal to 0. 6y plus 2x is equal to 0. Okay. So we have to remember what our tests are. So we're trying to figure out if they're parallel, perpendicular, or neither. Okay, so what does parallel and perpendicular mean in terms of slope? So obviously we know the definitions. Parallel means two lines never intersect. Perpendicular means they intersect at exactly a right angle. And neither would mean that they intersect, but nothing special about the intersection, right? They happen to cross paths. So we test for parallel and perpendicular by doing something with the slope, right? So I'm going to come right down here, right? And I'm just going to write this down just for our sake. So if they're parallel, and anybody can answer here, if they're parallel, what should the slopes be? What is our test for the slopes? If two lines are parallel, their slopes should be, and then you guys fill in the blank. So our slopes, I'll call them M1 and M2. Yeah, Keji, exactly. Yeah, you guys all got it. Exactly. They're supposed to be equal, right? So our test is, okay, if they're parallel, then the slopes are the same. Yeah, so we just would compare the slopes, and if they're the same, then great, the lines are parallel. If they're not the same, then they're not parallel, and it's that easy. What is the test for perpendicular? This one is the slightly more complicated one, and feel free to write it however you remember. I put it in two different ways in the video, so however you guys remember it.
M1 times M2 equals -1.
M1 times M2 is equal to -1. Exactly, right? They are negative reciprocals of each other. If you're solving for a specific, that's supposed to be an M and not an N. I realize that looked pretty bad. There we go. If you solved for a specific slope, so if you solved for M1, that means dividing, both sides of this equation by M2. And on the right-hand side, you would have -1 over M2, right? And then if you did the opposite, if you were solving for M2 instead, same thing, right? You're dividing by, M1, the first slope, and you would have M2 is equal to -1 over M1. So the point is that they're negative reciprocals of each other, which means that when you multiply them together, you should get a -1. So the first test is really easy. You just set them equal to each other and say, hey, are they equal? And if they're not, then great, they're not parallel. The second test involves a little bit of math. You're just multiplying them together. And if you get -1, then they are perpendicular. If you get any number other than -1, however, then they are not perpendicular. And if you do both tests and both of them fail, then you have showed that they are neither parallel nor perpendicular. They're just two regular old lines that happen to intersect at some point. that we don't necessarily care about. Okay, so let's look at line 1. What is my slope for line 1? This one should be pretty easy because it's already in slope-intercept form, right? We've already solved for y. We have this +1 over here, the constant, that's your intercept. So what is my slope here? And I'll call this, again, M1, since this is line 1.
3.
3, exactly, right? So we have M1 is equal to 3. And we get that because our slope is always the coefficient of x, m times x. Perfect. So we have 3. And we know that we're going to set 3 is equal to something. We don't know what M2 is yet, right? Okay, let's go over here. And we have for line 2, 6y plus 2x is equal to 0. Well, we don't have this in slope-intercept form, right? We don't know what the slope is yet. So what we have to do is we have to manipulate our line, the equation of it, so that way we can get it in slope-intercept form. And slope-intercept form essentially just boils down to solve for y, right? If we've solved for y, if we get y by itself, then we're going to have x on the other side, and we're going to have some constant on the other side. Whether it's positive or negative doesn't matter. We know that positive or negative number is going to be our intercept. So we're just going to solve for y here. So I'm just going to put a little arrow here because I need, to make some room over here. So we have 6y plus 2x is equal to 0. Solving for y, that means I'm going to move 2x over. So I'm going to have 6y is equal to negative 2x. And dividing by 6, I'm going to have y is equal to negative 2/6x. And 2/6, we know that we can simplify, right? So simplifying this, it's y is equal to negative 1/3 x. And now, real quick, just because I just want to see if you guys understand, what's my intercept here? We know that this is in slope-intercept form, right? Because we solve for y is all by itself, and we have some slope in front of x. So what is my intercept? What's the hiding number here? Exactly, Deborah. 0, right? There is a +0 that's hiding here. You can always add 0 to anything and not change the equation, right? So the 0 is the intercept. We know that when we have y is equal to 0, that is our y-intercept. So it's crossing right at, the y-axis, at that 0 mark. So perfect. Great. You understand that. Okay, so our slope here is negative 1/3, right? That's the important part. So we now know that M2 is equal to negative 1/3. So we go back over here and we say 3 is equal to negative 1/3. Is this true? No, right? This is false. So obviously they are not parallel. So great. Parallel is out the window. You're done with that one. So now we move over to perpendicular, right? And we do the same thing. We plug in for our slopes and we just test it and see what happens. So plugging in, we know that the slope of of our first line is 3. We know that the slope of our second line is negative 1/3 is equal to negative 1. Okay, sure. Yeah, right. And when we multiply an integer times a fraction, we know that that just means we're multiplying the integer times the numerator. So we get 3 times 1 up top, which is 3 over 3, and we have that negative 1 out front. And 3 divided by 3 is in fact 1. So we have negative 1 is equal to negative 1. Yeah, that definitely works. So the two lines are in fact perpendicular. And you would just write a really short statement, either saying, writing it out entirely, the two lines are perpendicular. Or if you want, and you want to save time, because I'm all about saving time, line 1 is, you can use that perpendicular symbol that I talked about in the lecture video, and you can do that. And that's it. That's your final answer. You have now shown by testing using the slopes, m1 times m2 is equal to negative 1. You have shown that the two lines are in fact perpendicular. Any questions on this or on our process? Again, just to recap, our idea here was we know by definition of parallel and perpendicular. For parallel, we just set them equal to each other, and if they're equal, then they are in fact parallel. If they're not equal, then they're not parallel. For perpendicular, they're negative reciprocals of each other, so multiplying them together should give you a negative 1. So by using our tests, we just needed to find the slopes. For one of them, it was already in slope-to-intercept form, so we could just derive the slope directly, right? It was just the coefficient of x. For line 2, however, we had to manipulate our line. It was in the general form. We had to get it from general into slope-intercept. So we had to move it from general to solve for y. And once we solved for y, we saw that the coefficient of x was our slope, and m2 was negative a third. So when we multiplied them together, we got negative 1, and that shows that it's perpendicular. Any questions? Okay, cool. So let's go ahead and move on. Anything else from the homework? Otherwise, I imagine there's probably some questions from the midterm review.
Can we do the unnumbered question?
The unnumbered question? Sure, unnumbered question. We can do that. And Olivia, 53. Sure. I'm pretty sure 53 was from the wait, what's it from the last one? 1, 2, 3. Nope, that was definitely from this one as well. Okay, so why don't we do 53 first, and then we'll double back and do the unnumbered question, if that's okay with you guys. So let's see, 53. That one is find the slope and intercepts from the equation 3x minus 2y plus 6, and then also sketch it. Okay, so we're given the line 3x minus 2y plus 6 is equal to 0. So before we even try to worry about finding the slope, from here you could actually find the intercepts. Because what is an intercept? Again, the way that we find intercepts is we set whatever the opposite variable is to be 0, right? If we're trying to find the x-intercept, you would set y to equal 0, and then you just solve for x. And then vice versa, right? If you're finding the y-intercept, you would set x equal to 0, and you solve for y. So we could, from right here, and it doesn't actually matter what form the line is in. It could be point slope form, slope intercept, or general form. There's always going to be an x. There's always going to be a y. So you could actually just plug in your 0 for whatever your intercept is that you're trying to find, and you can do it right now. So let's just do that, and then we'll worry about finding the slope afterwards. Okay, so let's worry about our intercepts. So let's do the x-intercept first. So x-intercept means we're going to set y equal to 0. By definition, that's what an x-intercept is, right? The y component is 0. So if the y component is 0, we're going to have 3x. Well, negative 2 times 0 is just 0, right? So we could just omit that middle piece. If you feel more comfortable actually writing it out as negative 2 times 0 first, totally fine. But again, you understand that negative any number times 0 is just going to cancel out. So realistically, you just have 3x plus 6 is equal to 0. And now you just solve for x. So solving for x, we're going to move the 6 over. We have 3x is equal to negative 6. And divide by 3, we have x is equal to negative 2. And this tells you, once again, that by definition, your point of the x-intercept is negative 2, 0, right? For an x-intercept, there is no y component. It's just always going to be a 0 for the y. So that means our point is negative 2, 0. And then similarly, when we're doing the y-intercept, we're going to set x equal to 0 now. So that means that this piece here that I'm circling, that 3x, is just going to drop out, right? Because once again, we would have 3 times 0 is just 0. So that's going to go away. What we're left with is negative 2y plus 6 is equal to 0. Once again, we're going to just solve. So we'll move that 6 over. We have negative 2y is equal to negative 6. And same process, right? Just solve for your variable, undo multiplication. So we're going to divide. And dividing by negative 2 means we're left with y. Negative 6 divided by a negative 2. Negatives are going to cancel out. So we just have 6 divided by 2, which leaves us with 3. So we have y is equal to 3. And once again, our point, we know the x is going to just be a 0 because we found our y-intercept. So our point is 0, 3. Any questions on this so far? I know I kind of just blew through that fairly fast. So if you have questions, please stop me. I just wanted, to show you guys that you could do it entirely in the form that it's currently in. You don't have to do any manipulations to the line to do the x and y intercepts. Okay, so hopefully you guys are all good with that. Now, since we found our x-intercept and our y-intercept, the only last two things that we have to do are find the slope and then sketch the graph, right? And sketching the graph should be pretty easy because we already have 2 points. Remember, a line is defined by at least 2 points. So that now that we have our x-intercept and our y-intercept, we can graph this. But let's find the slope first. So finding the slope, we're going to start once again with 3x minus 2y plus 6 is equal to 0. We're starting with the original equation that they gave us. And we see that it is in general form. And when a line is in general form, it's hard to see what the slope really is. You could have some sort of intuition. You might be able to tell what it is immediately, like just doing some mental calculations in your head. But if you don't see it, then that's totally fine. And also, you would need to show your work on a test anyway. So let's go through and change this from general form to slope-intercept form. Because if it's in slope-intercept form, then the slope will just be the coefficient of x. So changing this into slope-intercept form, again, we know that we have the 3x minus 2y plus 6 is equal to 0. We're solving for y, right? That's how we get it in slope-intercept form. So I'm going to move that 2y over to the other side because it's negative. So we're going to have 3x plus 6 is equal to 2y. And by adding the 2y over, now we're isolating y, right? There's only one last thing that we have to do, and that's divide by 2. If we divide by 2, then y is entirely by itself. So dividing by 2, we have y is alone now on the right-hand side, and we divide each piece of the left-hand side by 2. So 6 divided by 2, or positive 6 divided by 2, is 3. And 3x divided by 2 is, well, you can't really simplify that, right? 3/2 x. And that's it. So we have, and if you want to rewrite it, because normally you have it reading from left to right as the y coming first, you can just move, flip it, the equation over. So y is equal to 3/2 x plus 3. And for the sake of it, I feel the question coming. It's probably burning in your mind. No, you absolutely do not need to go from here to here. From that step. I only did that because, again, I'm sure you guys are used to seeing it read as y is equal to, and then the equation of the line, right? So if you just left it as 3/2 x plus 3 is equal to y, totally acceptable. There's nothing wrong with that. So great. We now have solved for y, and it's now in slope-intercept form, right? This is my intercept, and this is my slope. So we now know that the slope is m is equal to 3/2. And once again, just to really reiterate what slope means, this gives you a really nice calculation that from whatever point you're starting at that's on the line, if you move 3 units up in the y direction, you will also be moving 2 units over to the right in the x direction, and then you'd be good to go. I got the slope as a negative. Did I make a mistake? Let's see. Very possible. So we started with 3x minus 2y plus 6 is equal to 0. It was a negative 2y, so we added it over. So we had, just the positive 2y on the right-hand side. We divided by 2. This all looks pretty standard to me. I'm not sure where you're getting the negative from. But if you see a mistake in my math, please feel free to, take care of it. I isolated y on the left. Sure. So if we do it again, so if we have 3x, I'm just going to do this all over again. 3x minus 2y plus 6 is equal to 0. If you isolate y on the left-hand side, you're just going to be ending up dividing by a negative 2, right? So that means that you're going to have negative 2y here. And that means that you've moved over your positive 3x and your positive 6. So that means they're going to also become negative on the right-hand side. So you're going to have negative 3x minus 6 over here. And notice that because we're going to be dividing by a negative 2, we're going to have y all by itself, right? Divide by a negative 2. But again, notice that what we're dividing, the pieces that we're dividing are already negative, right? So we're going to have a negative divided by a negative for all of these, and the numbers should come out to be positive, right? Negative 6 divided by a negative 2, negatives cancel. We still just get a positive 3. And negative 3 divided by negative 2, negatives still cancel. We get a positive 3/2, and then the x just comes down. Hopefully I cleared up any, confusion with doing it that way. But either way, regardless how you did it, you should get your slope as 3/2. Yep, no worries. Okay, great. So we found our slope. We found our intercepts, right? Our intercepts were -2, 0, and 0, 3. So all we have left to do is just graph this, right? So hopefully you guys are not going to be too mad at me if I just freehand this. If you really want it to be accurate, I'll use the ruler. But freehanding this, I know that I have to be 3 units up in the y-axis minimum, and I also have to be -2 units over. So we'll just draw a standard coordinate plane, something like this. So 1 unit to the left, 2 units to the left. We know that this -2, 0 is going to be this point right here, our x-intercept, and 0, 3. So 1, 2, 3 units up is going to be the y-intercept that we're going to have. So that's 3. And all we have to do is just draw the line that connects the two. So drawing the line, this one I'll actually use the ruler for. Our line is going to look something like that. Yeah, it looks pretty good. And don't forget to put your arrows at the end just to show that it is in fact a line, not a line segment, just to show that it is continuing on to an infinity in both directions, right? So it's going downwards forever, it's going upwards forever. And if you really want to make me happy, because I love seeing this, write the equation of the line that you found. So you could start with the original if you wanted, 3x minus 2y plus 6, or you could write it in the slope-intercept form, which we found it as y is equal to 3/2 x plus 3. So y is equal to 3/2 x plus 3. And you're done. That's it. And if you really want to, label your axes, x and y. Any questions on this problem? Olivia, I know that you had asked this one, so I just want to make sure that we're all good. Not singling you out, but I know that you were the one that asked it. Are we all good with finding the intercepts, finding the slope, and then sketching this? All good? Okay, fantastic. And then I believe that Kaji had asked for the unnumbered question at the end of the homework, right? The one that I mentioned at the end of the lecture video. So let's go ahead and try to tackle that one. So I am not going to write down the entire, because it's a word problem. I don't want to write down, everything. It's going to take me forever. So hopefully you guys have it pulled up in front of you. I'm just going to pull the information from it, but I'll read it aloud really quickly just so we're all on the same page. So the unnumbered question, the last homework problem says the amount of bacteria in a petri dish follows a linear regression. And if you don't know what a linear regression is, just think about the key word linear. It just means that it's following a line. Regression, generally just means that it's going downward or upward or something, right? So it's a line. That's really all you had to know. So it follows a linear regression. At time is equal to 9 hours, there are 11 bacterial cells. Okay, that's good. That's good information. We'll see why in just a second. If the rate at which the bacteria multiplies is 2/3 cells per hour, how many bacterial cells started at the beginning of the experiment? And also, how many hours will it take from the start of the experiment to reach 29 bacterial cells? Okay, so first things first, again, we just said it's a line, right? So great, this problem obviously fits in with the rest of these problems. And if you didn't know what linear regression was and you didn't see the keyword linear, implying line, just think, what is literally every other question on this homework about? Oh yeah, this chapter is about lines, right? So this should probably be another homework question about a line. I wouldn't just randomly throw you a curveball that this is, some sort of circle or parabola or something. So great, this is a line. Okay, and now the first piece of information that they're given to us is that at time is equal to 9 hours, there are 11 bacterial cells. So before we move forward, let's go ahead and just draw quick graph, right? We know that it's going to be some line, and we know that obviously the rate at which the bacteria multiplies, again, it says it's 2/3 cells per hour, but that's positive, right? It's not negative. So we know that our line is still creeping upwards. I don't know how our line's going to look, but just to quickly sketch, it should look something like this, right? And in general, you're always going to have your x-axis as time. If you set this up with your y-axis being as time, you could do that It's just you're going to have to flip your equation around. But this is going to be time, and the number of cells, which I'll try to write coherently here, number of cells is going to be your y-axis. So the amount of cells is based off of time, right? And we talked a lot about independent and dependent variables, right? Where one is dependent on the other. That's, by definition, of dependent. Independent variable here is definitely going to be time, right? Time just goes. There is nothing that influences time. Time is just a constant. Time just continues on positively, forever, right? And then the number of cells is based off of how long that experiment has gone on, right? If we start from 0, so again, our origin, right, in a coordinate plane, then we know then that after some amount of time, there will be some amount of cells. So the number of cells is very clearly the dependent variable, and time is your independent variable. So time would probably be best suited as your x. This was probably the hardest part of the question, is figuring out which, how to set this up. But once it's set up, then the rest of this kind of falls out naturally. So again, our first piece of information that they give us is that at time is equal to 9 hours, there are 11 bacterial cells. Well, what is that? That means that when our x is 9, our y is 11. That's a coordinate. That's a point. So we know that they gave us this as a point, 9, 9 comma 11. That's our first ordered pair. So we have an ordered pair, and that's just given to us. And then it says the rate at which the bacteria multiplies is 2/3 cells per hour. Well, when we think about what that means that we're moving 2 cells, we're gaining 2 cells, and which is, again, according to this, our y, and we're doing that over the course of 3 hours, right? Which is our x. That sounds a lot like change of y over change of x to me, right? So 2/3 cells per hour is your slope. So they gave you a point, they gave you the slope, and they just want to know how many bacterial cells started at the beginning of the experiment. Well, let's get it into point slope form, and then we'll, go from there. So point slope form, once again, is, and I'll write this down as well, m is equal to 2/3. So point slope form is as follows. Hopefully you guys remember, because this was from the first part of the lecture video. So y is equal to y1 is equal to m times x minus x1, right? Okay, we know that our slope is 2/3, right? So if our slope is 2/3, all we have to do is, okay, we're just going to simplify this down a little bit. So our slope is 2/3. I'm going to plug this in for our m. And I'm going to also plug in my point here, because what I want to do is I don't want to just leave it in point slope form. I want to kind of reduce it down to slope intercept form. And we know that we can always move it from point slope to slope intercept form once we've solved for y. And we solve for y after we've plugged in numbers, right? After we have values for y1 and x1. So I'm going to have over here y minus 11. That's my y component. And over here we have x minus 9. And now all I have to do is I just have to simplify this down a little bit, solve for y, and it'll be in slope-intercept form. Once in slope-intercept form, we'll worry about the rest of the problem. But I again, just want to get the equation of the line in as simple of a form as possible. So in doing so, that means first thing I'm going to do is I'm going to distribute the 2/3. So we have y minus 11 is equal to 2/3 x minus, and now 2/3 times 9. So 2/3 times 9, that means you're multiplying the numerator times 9. So if I write this out over here, 2/3 times 9, you're multiplying your numerator times 9. So your numerator is 2. So you have 2 times 9 up top, which is 18. And then 18 divided by 3 is 6. So this one simplifies out to be really nice. We don't have to worry about a fraction over here. So it's just minus 6. And now solving for y, there's only one last step that we have to do. So I'm just going to add 11 over. And that means I'm going to have y is equal to 2/3 x negative 6 plus 11. That's going to leave me with a positive 5. So we have y is equal to 2/3 x plus 5. And now we have a line, right? Now we have an equation of a line, and it's in a super simple format, right? We don't have to worry about point slope form. We don't have to worry about this mess, right up here. We have it in where we know what our slope is, we know what our intercept is. So great, that's perfect. And now what we have to realize is what the question is asking of us. The first question is asking how many bacterial cells started at the beginning of the experiment. So if we're talking about the beginning of the experiment, that's where time is equal to 0, right? That's where your x component is 0. And if your x component is 0, what are you really looking for here? You're looking for the y-intercept. You're looking for wherever it, however this started. So this line that I drew is not entirely accurate because this is saying that we're starting from 0 cells, right? But that's not really the case. I only drew that in the beginning just to, give you guys a brief indication of what the line is going to look like. But again, we know that we're starting from some amount of cells. It didn't just start from 0. So our task now is just find the y-intercept. Because again, that's going to tell us how many cells we started with at the beginning of the experiment when time was equal to 0. So if we're trying to find the y-intercept, what do? Well, that just means setting the opposing variable to be 0. So that means, okay, we come here, we have y is equal to 2/3 times 0 plus 5. And we know, just by definition, since this is our intercept, and when we plug in 0, we're going to see this anyway, well, 2/3 times 0 is just 0, so we get y is equal to 5, which tells us our point on the graph is 0, 5. So going back up to here, we know that the number of cells that we're starting with is 5. We know that we started with 5. So our line looks something like this. We're starting from 5 cells, and the number of cells is growing over time through, some, whatever our rate is. And in this case, our rate is 2/3. They tell us that, and that's our slope. So it's growing over time. But the important thing is that now we figured out that at the very start of the experiment, it's starting at 0, 5. So that's our first question. That one's answered. So now all we have left to do is how many hours will it take from the beginning of the experiment to reach 29 bacterial cells? So, okay, we know that we have this equation, right? We have y is equal to 2/3 x plus 5. What we have to realize is we're looking now for a particular point. The question is saying, we're supposed to end with 29 cells. So our y component of our ordered pair is 29. We're looking for essentially the x component. So we have this ordered pair that we're looking for. So to find that x component, all you're doing is you're plugging in 29 into your y into your equation. So down here, the equation that we had, you're just plugging in 29 into your y. And once you have that, you're solving for x. Because whatever your input, if you could solve for your input, we know what the output is. The output is 29. So just figure out what the input was originally. So to do that, again, we have 29 now instead of y is equal to 2/3 x plus 5. And now we just solve for x. So solving for x, we first, subtract 5 over. So minus 5 on both sides. We have 24 is equal to 2/3 x. And you have your choice here. You could either divide the 2 out first, or you can multiply the 3 out. For me, I'm going to divide the 2 out because it's going to make the number smaller. So dividing the 2 out, that means that we're going to have 12 over here, and we're going to have 1/3 x. And then we want to multiply by 3, right? Again, our goal is to isolate our variable. So multiplying both sides by 3, we get x by itself. And 12 multiplied by 3 is 36. So what we have just found out is that we have the ordered pair 36, 29. But more specifically, when we're talking about answering the question was how long does it take? And we've now determined that it'll take 36 hours, right? Again, the slope, the rate was in terms of hours. So you can just make that same assessment that the number that you're solving for is also in terms of hours. So 36 hours is how long it takes from the beginning of the experiment to reach 29 cells. So let's go ahead and recap this really quickly because I know that was a lot. Word problems always are generally a little bit more confusing than just, plug and chug. So to start this off, again, we know that we were given the ordered pair 9, 11, right? That was the information that was given to us. After 9 hours, we had 11 cells. 9 hours, that's our independent variable, right? We know that time just goes. There's nothing that's controlling that. So after 9 hours, the dependent variable of the cells came out to be 11. We also know that the line was going up at 2/3. So our slope was 2/3. We're gaining 2 cells every 3 hours. So great. We have we have an ordered pair. We have a slope. We can then get a line by plugging in into point slope form. So plugging into point slope form, we did, and we solved for y to make it a little cleaner. So we get it into slope intercept form. And the reason that slope intercept form was so good for us was because the first question was asking us how many cells we started with, which was essentially just asking us, okay, well, when x or time is 0, what was the intercept? So our intercept for y was just 5. So we know that we started with just 5 cells. And on our graph, if you were to, sketch this, you would have your y-intercept of 0, 5. And then the second question was asking us in particular how many hours it would take from the beginning of the experiment to hit 29 cells. So to hit 29 cells, we know that, I forgot where I drew it. There it is. So we knew that 29 cells was our y component. We were looking for this piece right here, the x component of that ordered pair. So to find the x component, we're just solving for x when y is 29. And when we did our calculations, we got 36. So it takes 36 hours to hit 29 cells. Any questions on this? Again, I know that this was not the most intuitive question. I expected this to be fairly challenging. So if you have questions on this, please let me know. Okay, so no questions on this. We're all good. We understand. Okay, so we still have about 10 minutes, a little less than 10 minutes left. I'd like to still answer any questions that you guys have, I guess specifically now from the midterm review. So if you guys have questions from that sheet, now would be a great time to ask that. We could probably get one question done today, and then any other questions that you have, you could either ask them during office hours later today or during Wednesday's class. So if you guys have a question, let's try to get one more out the door. For the record, just saying this, if you got through the entire midterm review sheet without having to really look up equations, you understood the whole midterm review sheet, you're in really good shape for the midterm. Again, the review sheet isn't going to directly correspond to questions that you're going to see on the midterm, but as long as you're understanding the concepts, you should do absolutely just fine. The questions on the midterm review sheet are either just as hard or slightly more challenging than the questions on the midterm. And I also want to mention, because I got this question and I don't think that there are 6 questions on your midterm. Each problem has at least 2 parts. So you're, again, going to need probably the full class period to get through it. And there is one bonus problem. The midterm is graded out of 50 points. And the bonus is worth 5 points. So you could, in theory, if you got everything correctly, you could get a 55 out of 50, which is essentially 110 out of 100, right? When you compare it to out of 100. So just prepare yourself. It will be a fairly long test because it's going to take that full hour block. But just prepare. Review everything from now going into the test, and you guys should be okay. I haven't seen anybody with a post in the chat with a specific question, so I'm gonna go ahead and assume that you guys have no questions for me for the last 5 minutes of class. So if that's the case, then I guess we can just end the recording here, and I will see whoever I need to see for makeup quizzes later today. Okay, so that's it, guys. Have a great day, and please let me know if you guys have any questions. Come to office hours, and yeah, that's it. See you later.